week 7. We covered most of the stuff we need to cover about residential oil burner. Next week we'll move into commercial, and you'll see how it's still the same, just bigger controls and more sensitive controls. And we're still doing troubleshooting. So this week for lab we did troubleshooting. Next week we'll do troubleshooting again. And we have some suggested causes for no heat. So if the primary control has no power, check the limits. Again, always start with the simple things. Check limits, check the power, check the fuses. Somebody reports there's no heat. Is the burner even working or not?
Would the limits be set that low?
Huh?
Would the limits be set really very low?
Could be the limit setting, but it cannot be too low, it's not gonna work.
Yeah.
Sometimes even the limit switches is broken, so you gotta check that. Check that the power coming into the primary control, check it's 110. If there is no power, you gotta go back and check the limit. Check the integrity of the wires and switches. Check the circuit breaker, fuse, and wire. With the circuit breaker, sometimes when it trips, you wouldn't know it tripped, but it will move by like 1/8 of an inch, and you have to go back all the way and reset it and make sure it has some power. Take out the breaker and look at it. Maybe it's broken or melted or malfunctioning. If the primary control has power, but no power is going to the burner motor, igniter, or oil valve. That's interesting. So you have power coming from the line voltage all the way to the primary, but nothing is happening. What could be the problem? Check that there is no fire in the chamber. Make sure that the cat cell is in the right location. Because if there is fire in the chamber, the primary control will not react. Can we put the phones away, please? So, if there is fire in the chamber, the primary will not react. Depending on what kind of primary you have, it should tell you. If you have the 3rd generation one, if the LED light is green, that means it's seeing the fire, so it's not going to turn. If it's flashing, go and check, see what's happening. If you have the 4th generation, the one with the LCD, probably it will tell you that flame is on. So check there is no fire. Okay, we check that there is no fire in the chamber. Next step, check that the thermostat is set above the room temperature. It's set above the room temperature. Okay, let's go and jump on the thermostat and see what happens. If it works, something wrong with the thermostat or the wiring from the thermostat all the way to the primary. So we jump with it, and if it works, I mean it's a thermostat. If not, we can go further. If the burner does not start, jump on the AFF terminal. If the burner starts, then the cat cell is bad. So it's going to be either the cat cell or the thermostat. If none of that work, the primary is faulty, something wrong with it. Change the primary. Again, if the primary control has power and passes the correct voltage, the burner and the motor runs with no flame. So the motor is running, inducer fan is running, but there is no flame. Disconnect the nozzle line and check for oil flow. Get a bucket, take the nozzle line, connect it. We did that last week with who? Yeah. What was the problem? Was yeah. So take out the whole nozzle assembly, turn it on, and put it in a bucket. See if it sprays or not. Maybe it's blocked. So check the nozzle line. If there's good oil flow, check the ignition system. So we have flow, we have oil. Second thing, it will be the ignition. Is it in the right place? Is it even igniting? Don't try to attempt to turn off both the oil and the ignition at the same time. You're gonna have fire in somebody's basement. So disconnect the motor and connect the ignition and make sure it's not jumping into the plate. It's in the right place. When you put it back, make sure that it's not hitting anything. Go inside and look and make sure it's like sitting in the right place and nothing is changing when you put it back. And maybe when you put it outside, it's okay, but when you put it inside, it's hitting some other wall. If there is no oil flow, check the oil valve and pump. Oil valve sometimes go bad and does not pass oil. If there is oil flow, perform a vacuum test, high vacuum. If you have high vacuum in the pump, that means that something wrong with the oil line, the incoming oil line. Clean the oil line. If the vacuum is low, check coupling. If the coupling is good, then check the pump strainer. Nothing works, do a complete pump test or change the pump. So the pump could be clogged, pump could be bad. it's not drawing enough vacuum from the line. So the vacuum is from the inlet, it's how much the pump can pull, and the output should be 100 to 150 psi. So it's for pump problem. If the primary control has power and passing the correct voltage, the burner motor, the motor runs and still there is no flame. We have good oil flow. Replace and check the nozzle so the oil is flowing but it's not the right pattern. This could be a problem. You take the nozzle out, it's spraying but it's not the right pattern, it's not the right concentration, it's not igniting, so replace the nozzle. Check the recommended oil pressure, make sure it's between 100 and 100 psi, whatever is on the label. Check the air setting. Again, we faced that before. If you have too much air, you will not have flame. So choke down on the air and reduce the air, play with it a little bit until it ignites.
A lot of it's the air, that's true.
Air is always an issue. If you have fuel, if you have ignition, the third component is the air for no heat. Burn on fires, but shut down safety. This happens a lot. Most of the time, it's the cat cell being displaced, disconnected, not functioning. If there's a stack relay for heat, make sure it's moving. So the other way to detect heat is stack relay. If we don't have a cat eye cell, check the cat cell, make sure it's running, make sure it's connected correctly. Take out the socket to make sure that one of the two legs are there. Sometimes it will be missing one leg and it's in place. Check the resistance all the way from the wires, make sure there's resistance. Check the air tube and the end cone. End cone and clean and replace. That's for the flow going in. Check the water on air and the nozzle line. It's background music, commercial. Check the water on the air and the nozzle line. How do you do that? If there's a bubble trapped between the nozzle line and the oil line, it will not go through. So you have to go and check that. Still, there is no heat, but this time the motor does not start.
Guess who's here?
Mark? You just start the hack a little bit, 15 minutes early.
Yeah.
That's okay. 7 more weeks. Serenity now. Insanity later. So check for motor does not start. Check the resets. There are two resets. One is the thermal reset, and the other one is the centrifugal switch. Check the motor circuit. Check the motor capacitor. If it doesn't work, change the motor. The motor is dead. You're not supposed to reassemble the motor and put it back together. Don't do that. Just make sure that the motor is running. There is no heat circulation. We have heat, we have fire. The thing is increasing heat, but no circulation. There are two things. Either we have hot water system, and what circulates the hot water? A circulator. Who controls the circulator? Which control? The aquastat. The aquastat tells the zone relay to go. Check the valve for open position. Make sure the valve for the flow is open. Nobody closes it for maintenance. Check the pipeline for pressure. Check the circulator. Make sure there's pressure of water inside the pipeline. If we have low water, probably it's not going to circulate. If you have bubbles in the pump, it's not going to circulate. What we're going to do? Purge it. There's always going to be a purge and makeup line in the boiler. So check the circulator, make sure it's getting enough voltage, it is circulating. Check the flow control valve. Check there is no air in the system. If there's air, the system is going to be airbound. This happens a lot more than you think. If there's bubbles in the system, it's not going to circulate. Whenever you change the oil or line, if there's some bubbles, it's going to impede the progress of flow. When you change your brake line in the car, don't you have to bleed it? You have to bleed it. Whenever you change something, you have to bleed and make sure there's no air. Air will clog the system.
So what is it, air is heavier than?
No, it's just an obstacle. If you think about it, you have to push against it. It's going to be there and clog things from moving. If you have a pipe, and we have water, we have a big bubble here. Hey you, it's 20 minutes.
I know my car like stopped in the middle of the road.
You hit the brakes.
Don't eat your sandwich or don't eat your homework.
It just shut off.
So if you have a water bubble, if it's small, it will sometimes get bigger and clog it. So it's gonna, and air is compressible, so you're just gonna push against it. If you don't have a strong pump, you're gonna have swooshing, and you're gonna push through it. If it's not strong enough,
Pushing on a
yeah,
hole from both sides.
exactly.
Yeah.
So it's gonna be there. It's not gonna go. So you have to push it. Check the high limit on the primary control. Check the reverse aquastat that's set properly. Aquastat, if it doesn't get the water between the two, the high and low, it's not going to turn on circular. Also check for that. Again, no heat circulation, but this time is the warm air system. This happens a lot. So for hot water, you want circulate water. For hot air, you won't circulate hot air. What circulates hot air through the duct system? Fan, inducer fan. So check the fan limit control. Limit control. Make sure the limit is okay. Make sure it's triggering. Check that all the dampers are open. Nobody close the damper. Check the air filter. This is very common. Air filter get clogged. You don't have enough air. It just does not pass through. And sometimes by the noise, when the system gets noisier, it means the filter is clogged. Check the air blower for operation. Is it actually running or not? What are the limits on it? Check the motor. Make sure that the motor is running, getting power. Check the belt. If the belt is loose, it might spin in its place. The pulley might spin in place and it's not going to push through. No heat circulation again for steam system. So steam does not require a pump. The steam goes by itself. And check the water level. If you don't have enough water, you're not going to make enough steam to circulate. Check valve that is there in the open position. If you have a valve on the steam line and the steam is not going through, it's not going to move. Pressure control setting, main vents, and circuit for solenoid if you have a solenoid. The other issue that you might have if you have steam system and there is no heat in one of the radiators as well. Every radiator has a vent. The vent gets filled with air. If the air vent is clogged, the air is not going to come out of the radiator, which means the steam have no room to come. So make sure the air vent is not broken.
That's some nozzles on the side of it.
Yeah. If you do not have enough heat, could be the burner is not sized correctly. So you gotta check, is this problem new or old? What caused it? Check the thermostat and control limit. Make sure the thermostat is reading the right temperature and it's reading at the right temperature. Check the water level. Again, we said if there is low water in the hydraulic system, you might not get enough hot water circulating. Check the water float. Phones off, guys. Phones. Put the phone away. Put the phones away. I'm almost done. You can play with your phone later. Too much heat. So we had too little heat. Either the burner is not sized correctly, the radiator is not sized correctly, the radiator is blocked, the filter is clogged, these resistors are blocked by something. So that's for hot air. For steam, we do not have enough steam. The vent is not venting air out of the steam system. If you have too much heat, thermostat will be stuck or faulty. Limit set too high. So if the water is, if this radiator is designed at 180 and you give it 200 degrees water, it's going to give you too much heat. So that could be a problem with the limit. Make sure you go to the aquastat and put the limit at 180, wherever these radiators.
Isn't there a certain amount, like, where you're not supposed to go above for hot water?
Yeah, what is that?
180.
Huh?
180.
200.
180, 200. What happens if you go above 200?
You can burn.
You can burn, yeah, you can burn.
What's a boil?
It starts to boil. You have steam. The steam is not. The system is not designed to handle steam. Water start to boil and steam at what temperature? 212. So you don't want to be there. So you're going to be at maximum 200. Above that, it's going to be steam, and you don't want to deal with steam and hot water. That will definitely be an issue.
Unless you want a sauna.
Huh?
Unless you want a sauna.
Yeah, it will go to your house and leak. Check the motorized valve. It's not stuck. Make sure it closes and open. Maybe the zone valve you have is always open, so it's going to be always overheating. Check the flow control valve that it's not also stuck and it's in the right position. Too much heat. No hot water. That's if you have domestic hot water system. Check the mixing valve. Check limit controls, vents, airflow, ductwork, air filters, radiators, water level and piping. These all things you can check for the hot water. Make sure that if you don't have enough hot water, by hot water I mean domestic hot water. Check the circulator and the tube coming from the boiler to the hot water pump, and check the flow control valve. What's the flow control valve? It's a check valve that allows the flow to go from one direction to another and not the opposite. Check that it's not broken or stuck in the closed position. If you have water leaks, first thing you see is check for expansion tank. This is the expansion tank. And in the other class, AST 205, we will learn how to size this expansion tank for this purpose. So you do not undersize the water expansion tank. What happens if you undersize it? It will leak. What happens if you oversize it? You not have the right system pressure. System will be under pressure. So you want to keep the system on the right pressure, and you don't want it to also be too tight, so when the water expands, it does not leak. So if the expansion tank is full, it means it's undersized expansion tank. Improper setting of the aquastat, as we said, you put it too high, the water expanded too much, the system went down at 180, and suddenly it's at 200. Yeah, that's what they want. The water stays too high, what happens? The water will expand more than it's supposed to, and eventually it will leak. So if it's at 180, make sure it's set at 180. Check for the coil leak inside the boiler. Do not fix a leaky boiler. So you'll see a lot of those quick fixes like glues and gypsum, whatever. Those are for temporarily for a few hours, but if the boiler is cracked, you have to change it. Do not fix a leaky boiler. Do not fix any coils inside the boilers. You change the coil completely, otherwise it will leak. Circulator leak as a design for protection for the bearing. Some circulators do leak, but check the manual and make sure that it is designed to leak. We have an oil pump here, a water pump here that pump in the condensate all the way to building 17. And it is designed to leak a little bit from the bushing. And that little water, it protects the bearing and provides some kind of lubrication. So it's supposed to leak a little bit, but that's an old design. They don't do pumps like that anymore. That will use water to lubricate itself. The flange, so pumps have flanges and bushing. Because if you think about it, this is a circulator, this is a motor, and this is the pump part. If you think closely, there's a shaft going on from the motor to the impeller. There's water in here, and there's no water in here. There is a flange or a bushing that will prevent the water from transferring from the shaft into the motor. So if you look at the pump on the inside, this is the shaft, this is the impeller. There's water in here. This is the motor. So how come the water is not coming out from this little opening? It's very, very small and sized correctly, like to the micron, so it will not move. Over time, with spinning, it might leak. And usually they put a lot of flanges and bushing in here. They'll provide some kind of cushion for the water not to leak. And of course, as the water gets hotter, it will expand, and also water will be thinner, and it might leak. Example, when your car starts to burn oil, what happens? The same thing. The piston rings, expands, and push against the wall of the cylinder to wipe all the oil down. When the motor gets old, water starts to seep from the bushing and burn the combustion chamber. So So over time, this has to be changed and maintained, but you also have a flange in the pump. Check the chimney if the leak is during the rain. So if your system starts to leak, a lot of people neglect that part. Maybe your chimney is not covered properly. Maybe your chimney has some condensation. So make sure that the leak actually is coming from the boiler and the pipe is not from the chimney. Condensation. When will we have condensation in the chimney? That's a very important question.
Too much steam going up here.
Okay? So the chimney has flue pipe gas. It's combustion gas. That combustion gas has to be coming out at least 350 degrees Fahrenheit. If it's less than that, it's not hot enough to get out of the house. By the time it reaches the top of the chimney, it's cold and it starts to condensate. What is the problem with that condensation issue?
Drop it back down into the chimney.
And what happened?
Smoke and.
It will corrode because it had a lot of sulfur in it. Think about it this way also. When you turn on your car in the morning, doesn't it drip from the muffler? That's condensation. As the car heats up, it doesn't drip anymore, right? It's hot enough that it will evaporate everything to the outside. So if the muffler system is not high enough, and you're gonna have a lot of condensation inside your car, or if it has a leak in the beginning, so it doesn't go all the way to the back, eventually you lose the entire muffler because it will rust and have a lot of condensation and sulfur accumulation in it. Okay. How much do we have? Well, we're almost done. If you have oil leaks, check the fittings, gaskets, pump seal, and nozzle adapters. Now, pump seals has to be changed, the seal between the pump and the motor. If you take the pumps out, you have to change the seals. Most gaskets are not designed to be pressed more than once. Remember that. Check the nozzle adapter, that is not stripped, but there's no cross-threaded phones, guys. It's really old trick, you know, putting your phone in your lap. We know this. Nobody's like looking at the labs much. Just pay attention. Only I'm almost done. After drip problems, that's when you turn off the pump and the nozzle will keep pushing some oil through. Oil lines, check for the fittings and for condensation from the outside. And finally, check for spills. Maybe the spill is old and hasn't been cleaned properly. Smoke, odor, or soot. Combustion. So if you have smoke or odor, it's always a combustion problem. Could be a ventilating issue. So check the timing on the oil valve. Make sure it's not too long. What happens if you pump oil for 15 seconds and then the ignition comes? You're gonna have a puff. You're gonna have a small kind of a puff and smoke. That will cause some soot. It's okay if it happens only in the beginning, but if it continues to happen, something is wrong. You have to double check that. Check for venting problems. One of the vents is blocked with draft doors, and it could be that there is not enough air coming in. So the system is burning very lean. Not enough air. The most important part is check the heat exchanger, especially if you have a furnace or hot air system, because this can kill some people. If somebody reports to you that, okay, the air smells funny, what's happening? The air handling unit has a crack in it, and the combustion air is being mixed with the circulating air.
Carbon monoxide poisoning.
Yeah, that is a big issue. You will rust your duct system, and you might kill some people. So be very careful with that. How do you test for that? You're gonna have to perform a smoke test. You put smoke inside the chamber and look for leaks, and you might have to pressurize the duct system to make sure there's no leak. Heat exchanger, if it's cracked or broken, what do you do?
Replace it.
You contact the manufacturer and replace the entire thing. You do not weld it, you do not change it, you do not put a glue in it. Again, it's subjected to a lot of heat. It gets up to like 600 degrees hot. So nothing will work. They have some special things, but you cannot do it yourself. It's not something you do on the spot. They take it, they put some ceramic glue on it, and they bake it, and they retreat it again. So it can be fixed, but it's not even worth the effort. So you can change the heat exchanger completely, otherwise you might have to go and get a new burner. Check the fans. Sometimes the fan gets burnt out, or like they get something stuck in him, so check the fan is not giving off smoke. If you have noise, again, optimally the car should run smoothly, the system should run smoothly, you should not hear any irregular noise. If you have any noise, it's gotta be something that's on the verge of breaking. Pump gears could be broken, impellers could be missing one of the fins. Vacuum. There's a vacuum in the line. Air in the line could cause a noise, swishing noise. Vibration. Vibration is the issue of something being imbalanced, or the coupling may be about to melt. If you have really high vibration, check on that and make sure it's not an issue. It gotta be a rotary issue. If something is rotating, it's prone to have imbalance and vibration, and eventually something will break. Also check for spills. If you have noise, it drips, something is spilling. So in conclusion, you have this diagram. I gave you a sheet of the copy back and forth with the no heat coil. This could help. In the beginning you will use this a lot, but within a few months of doing this, you will start to have a sense of what could go wrong. And those are built with experience, and always remember that the parts are always going to be the same. If when in doubt, consult the manufacturer, especially if the equipment is new. Call and say, this is like shutting off for safety, this is leaking, is this normal, what's happening? Sometimes there's a recall. The more you practice, the more you'll be able to pinpoint the problems. So probably now if you have shut off and safety in 15 seconds, probably you'll guess it's the cat cell. And it gets much easier. There's not a lot of parts. Attitude is very important. Like, go with an open mind, everything is possible. And I know it could be frustrating sometimes, we spend a lot of time and things do not make sense. Just give it some time. If you don't know, don't try to like be a hero. If you don't know what's going on, not having to consult somebody, don't just try to adventure in somebody else's expense. Okay, so this concludes our troubleshooting for residential. Next week we'll start doing some commercial stuff. It gets a little bit involved, but it's the same concept. It's going to be just a bigger boiler on steroids. That's all. It gets me difference. Okay.